My name is Dr. Julian Goskin, and I've written you a few times. And I recently wrote you another letter about what I believe can happen in the Gulf because of the oil. And I want to conduct a little experiment this morning to prove my point to you and lots of other people. But the premise is this: because the oil is on top of the water or just below the surface, and because of its color being so dark or black, it's going to conduct heat into the water faster and at a greater rate than ever before, which means the water is going to get hotter and to a higher temperature than it's ever been before, which could kill a lot of animals. But the real concern here is what's it going to do to hurricanes. Hurricanes feed off the temperature of the water and the water itself, and it's already stated that because the oil is on the water doesn't necessarily mean it's going to reduce the amount of water vapors going into the hurricane. That's not going to change. What's going to change is the temperature of the water is going to be a lot warmer, which means hurricanes are going to get a whole lot worse. And we've already got a forecast of a very active season. Well, I think we got probably one of the worst seasons we've ever seen on the way. But anyhow, let me explain the experiment real quick. I got 2 flood lamps, some equal amount of water, something to project the flood lamps, and 2 pans to simulate the ocean. One of them is larger than the other, and that's because the one that's larger is not going to have the crude put on it. I'm trying to force the issue and say that even though there's a greater surface area heating, it's still not going to heat as fast as the one with the oil in it, because it's going to conduct the heat faster. Now let's get on with the experiment. What we're going to do here is I'm going to use the cup, and I'm pouring water into the cup, and I'm going to put it at the exact same level so both pans get the same amount of water. Okay, that's right at the tippy top. And she goes. And we're going to take the temperatures of both pans and make sure they're pretty much the same. So we're starting at the same equal temperature. Okay, same exact amount of water. In the other pan it goes. This cup over here has some dirty motor oil, and it's going to simulate the crude, which is very, very close to what crude is. Basically dirty motor oil. Okay, next step here. We're going to take the temperature, and this is a fast-acting thermometer, so we should get a pretty accurate temperature fairly quick. Okay, and it's dropping down to right at, it looks, well, we're going to leave it set there a minute, and then we'll come back and do the same for the other one. I think that'll give us an accurate temperature. Okay, it's dropped to right at 61 degrees. Okay, that one's 61. Okay, now we're going to check the other one. We expect it to be 61 as well, but to counter it, let's raise the temperature back with my body. It's gone up to 80 degrees. I'm putting it back in the water so we have the same temperature of water. Okay, we're going to let that temperature, and once again it's exactly 61 degrees. The same temperature, both waters. Okay, now goes in the crude oil into the little one. Nasty, horrible, rotten, sludgy, ugly looking stuff covering the water. Okay then, the next step is to set up the lamps. Now, to maintain accuracy, because I dumped a bunch of oil in there and I had no idea what the temperature of the oil might be, I'm taking a second temperature of the crude oil side of the ocean here, and it's still 61 degrees with nasty crude oil all over it. 61 degrees. Okay, now we're going to turn the lights on, begin heating the water, and we're going to see what happens. As you can see, both the same wattage of bulbs pointed in the same angle at the water, so it should equally heat the water equally. Now let's see what happens. So that all aspects of this experiment can be observed, you can see that I have a timer running, and I set it for 30 minutes. And after 30 minutes we'll come back and check the temperature again, but anyhow, so that you can see that the angle of the light is equally the same in both containers, and they're going to heat supposedly equal. And we will see. To the water. Okay, now for the test group. This is the control group, this is the test group. Okay, right about here in the center. Okay, here in the very center, where the heat is being directed the greatest, I have a temperature of 128 degrees. 128 degrees. Now for the control group. Here, right here in the center, once again, it's dropping considerably. Remember, I had 128 degrees over here. The same light, same wattage, same angle. The water temperature over here is a cool and calm 109 degrees. We literally have a 20-degree difference in temperature between the one that's clear, our control group, and the one that has crude oil on top. I think I've proven my point. In 30 minutes' time, there was a 20-degree temperature rise greater in the one with the crude than the one that's clear. And there's a greater surface absorbing the heat in the clear one. So even in a more limited space, it's still getting hotter.
Hi, this is Dr. Julian Goskian, and I wanted to take a moment to sum up. What you just saw was an experiment using basic scientific method to discover what we already know: darker objects absorb more heat than lighter objects. It's just a natural conclusion that the water is going to heat up a little more this year because the oil's sitting on the top of it. The sun is going to be focused better. With that said, BP is probably going to continue to fumble around trying to clean this up, as well as our government, and before long the whole Gulf is going to be covered in this oily sheen. That's going to raise the temperature of the water terribly, and there's no telling what that will do to a hurricane. I don't know, and neither do the other meteorologists. So I think, to be prudent, everybody who doesn't need to be down at the Gulf should leave. If you want to stay there, protect your property, send your children to the north. But be ready to get out at a moment's notice for anyone on the Gulf this year. This could potentially be the worst hurricane season we've ever seen. We really don't know. I hope I'm wrong. But to be prudent, start taking action now. Hi, Ed. I wanted to thank you for displaying this. I'm really concerned about the people on the Gulf this year. I feel so bad about what this could potentially do to New Orleans again after Katrina and such horrible things that have happened there. To get another blow like this, it just could send New Orleans into the Stone Age forever. But don't sacrifice your life for your property. If you can get out now. Thanks, Ed.